So I'll start off by clicking away from the splash screen, A to select everything and delete. Just then we add in a curve bezier and look from the top. And what I'm going to do now, tab into the edit mode and delete every vertices and click on this draw. The second actually, the first one is annotation, and simply just draw like this, or not, maybe something more smoother, something that goes like this. You can draw in any kind actually, but I'm just doing it to make for demonstration purposes mostly. Okay, you don't really have to do the way that I did. This is just for demonstration purposes. Then I'm going to add in a curve cycle. I'm just going to move this to a new collection, which I'll just call it profiles. Okay, and I'm going to scale this down, something like that, and I'm going to duplicate this to somewhere there. Then I'm going to tab in, and maybe I'm going to select these points and scale them along the X, and one of them just along the X again, something like this. A bit funny, but only for demonstration purposes. And grab this one to the very end, and again I'm going to select this one, this cycle, and duplicate it, move it to somewhere there in the middle. And now I'm just going to subdivide this, select one point with the active element, go to select, then check a deselect and scale it to shape it like that, any shape that you want, but I'm just for demonstration purposes mostly. And take this cycle here and tab here, and maybe I can take this one, grab it and move it along the Y, something like this. Grab this to somewhere there, grab this somewhere there, and to make this kind of shape that you're seeing right now. Yeah, mostly that. And maybe we can duplicate this, and from this one we're going to change something very small. Maybe it shouldn't have this point, like that, although it looks funnier now. Maybe I bring these points closer and something like that. Yeah, it looks more distinct from that one. And we are done. So I'm just going to hide the profiles, and let's deal with this curve that we want it to be lofted of a sort of. I'm just going to reduce the spreadsheet after going to the geometry and workspace, click on the new and pin this, and maybe rename this first to lofting, and like that. I'm just going to something feels odd, maybe the naming. Okay, that's how it is. Lofting. Anyway, it's not really big of a deal, it's just naming. So first thing that we have to do is to resample, okay, this curve, because we actually the points that are here, we need them to be enough so that we can make some curves actually loft in that path. So I'm going to change it to length, and I'm going to have some bit of control via the output here. So I increase it, it becomes blocky, I reduce it and it becomes very smooth. So I'm just going to leave it maybe at 0.2, and afterwards I can convert this into a mesh. So curve to mesh, something like that. So what are we going to use these profiles for is sort of loft this, so such that at this very end here the profile will be resembling this one, and as it goes along this path it will resemble this shape here at this point, and as we go it goes along these curves how they are shaped with, sort of like a curve to mesh, but in the profile curve we can connect curves and sort of have a certain lofting kind of thing happening. So how we're going to do that is, first of all, we want to sort of rip some vertices here. So how we're going to do that is we're going to rip them based on this collection via proximity, and a very close proximity, almost very accurate. So what I'm going to do next is maybe hide the 3D cursor as well. And what I'm going to do now is add in a collection info node and set it to relative. And for the collection I'm going to choose profiles, separate children, and input, connect it to the group input, because I actually need control this, so to control this which collection that I'm dealing with, because in the near future I might not have these profiles. So that's why I did that. So next up I'm going to change this to points, but not actually mesh to points, it's instances to points. Okay, so to points, instances to points, because this collection info outputs instances. Okay, but we are going to be in need of the points. So then here I'm going to connect a sample nearest. Okay, sample nearest. And what we're going to do right now is that if I connect this curve to mesh and view through the index here, we see some points have a value of 3, then 4, then 0, 2, then 1, viewing via this viewer node in this spreadsheet. So we want that points that have a value of 1, points that have a value of 2, points that have a value of 3, which one has the minimum distance, like which one has the smallest distance from these points here, from this node in this state. So we're going to find out how we're going to select those points in this fourth step. So another node that I'll be in need of is the proximity node, geometry proximity node, and looking at the points. Okay, simply like that. But here as well I'm going to convert this into points, so mesh now to points. Okay, mesh to points like that. Let me just hide the profiles, and I'm going to now set their position via a combine XYZ, and now every point are at the center here. So I'm going to set their position along the X based from this sample index, and now we are seeing points here, here, and to that point. Then their position in the Z is going to be dependent on this distance from the geometry proximity node, and right now we're having points arrayed in this fashion, which is actually what we need. Let me just hide the origins. Afterwards we're going to convert this to vertices, so points to vertices. Then I'm going to extrude these vertices, but we're going to extrude them at an offset scale of 0. Now they look disappeared, but they didn't. They're actually there, but they are very small, their edges are very small, that's why we can't see them. The edges have like a length of 0, that's why we can't see them. So afterwards we're going to set the position of the top. Okay, then afterwards in the position I'm going to connect in a math node set to multiply. Suddenly we see vertices. but we're going to multiply the position times 1 in terms of the x and y, but 0 along the z. So I'm going to offset the top a little bit, offset along the x and also along the z to somewhere there, and later I'm going to merge by distance. And to be more specifically, to avoid errors that can occur, we're going to connect in the top as the selection, and simply like that. Then afterwards we're going to dive into mesh topology nodes. So now we are having all this. Okay, you should know that this is one mesh island, this is one mesh island, this is one mesh island. If you're not familiar with what mesh islands are, it's like, try to imagine that these are actual meshes, not procedural, and you can tab into edit mode and actually select a vertices, a single vertex. Now imagine that point as in you press Ctrl linked on that vertices, that mesh, that mesh that will be selected at that point, that will be like one single mesh island. That's what a mesh island is. And in each mesh island we have one single vertex that has the top attribute, top boolean attribute of 1, and we want it in its index in order to find which edge has the minimum position, and through that edge we can isolate the vertices that has that has the lowest position in terms of the z. So afterwards I'm just going to connect an edge of vertex to somewhere there, and in the weights here I'm going to connect in a separate xyz and connecting position. Okay, leave it to 0 in the sort index, but in the vertex index here we actually want the index of the top in each case, in each mesh island. How to do that is we're going to take this boolean attribute and we're going to multiply it by the index. Okay, the index of each point. Okay, and afterwards we're going to connect this to an accumulate field node, and in the group index we're going to connect in the mesh island index. And by doing so, and for more accuracy actually it's better we connect it to integer, and by doing so we have number values like 54, 55, 56 and 57, 58, which are accurate in our case. In this case, if you have a different value in the length, you'll get different values as well, and different curves. In my case, we have that. So just connect the total into the vertex index and we'll be getting something like that. Okay, and in each case they have their own value here in the edge index, but what we want to do is actually duplicate this. So shift D and connect it there. We want to say which one is equal. Okay, actually connect the edge index here for this, from these two edge index, who has the same value in the result. And what this would mean is that this vertex here might select this edge based on this sort index because it's the top. Okay, and it has this weight, but for a vertex at here, at this very point, no matter which kind of weight you will select, it will always be this point, it will be this edge, because there's only one edge connected to it. Okay, and at 0, at any value, the value will still be the same. You can see that I'm playing with the values here at the very bottom, and that doesn't change the value here at the very end. So I'm going to say which one has equal, and at the same time is not the top. Okay, is not the top from here, doesn't have the boolean attribute of the top. And let me check, and yeah, that's more accurate actually. So what I'm going to do now is separate geometry, and I'm going to use this attribute here to separate. And by that, if I can just mute and unmute this, you can see the vertex that's selected has the lowest position in the z axis for each mesh island, and that's actually what we want. Okay, so next up, I'm just going to set their position back to the original state, meaning that I'm coming back here just to capture the attribute, and that attribute is a vector position, and connecting this to where, yeah, to here, and looking from the top. And if I unmute the profiles, you can clearly see that these vertices are very close to these profiles, which is something that we definitely want. Okay, let's just now go back to this original mesh by Shift Alt select this part, and maybe delete the viewer and this one as well, and just move the group output somewhere there, reroute this somewhere back there, which is better, and grab this to somewhere there. Now we're going to use geometry proximity node, okay, to something like this. I want to say, and we'll change this from faces to points, and we're going to say the position from here should be equal to the position, okay, in terms of proximity. And if we now check via the viewer node and maybe convert this to curve in order to see it better, grab this somewhere there, you can see that the points selected here, these points that are white, are very accurate to what we actually want in each case. And we have to increase something, and we have to add a certain boolean to it, and we want to say, and it should have vertex neighbor equal to 2 in number. Okay, vertex neighbor in the vertex count should be equal to 2, not 1, because the aim was doing vertex ripping based on proximity, very close proximity. So I'm capturing this attribute here, which is a boolean, and select it there. I'm going to extrude the edges from this original mesh, not the vertices, like this. I'm going to do splitting of these edges based on the original attribute that we captured. Okay, before we had 108, now we have 101.14, but we don't really need these newly formed edges from this extrude mesh. We just needed them to do sort of vertex ripping. So I'm adding in a delete geometry and connecting the top into the delete geometry node. After doing that, if you just mute and unmute this, you can see initially you have 54 points. Now we have 57 points. I checked via this row here. So I'm going to convert it back into a curve. So mesh to curve, and I'm going to connect an instance on points like that. And in here, I'm just going to connect in the collection info and shake relative, separate children, reset, and in the input, like that, we are getting something like this. And it's very messy because each of the instances from here is being set to sort of be in each point, so we have to pick them. Now it's a bit better, but it's less controlled. So what to do is simple. So from here, I'm just going to do a shift control D, and again I'm going to convert this into points to points. Okay, instances to point. I'm going to use a sample index, sample nearest, actually sample nearest, and like that, simple as you can see. Then afterwards, after sampling by nearest, is that we want the, in this instance index, in each spline that we have here, because right now after splitting we have 4 splines, in the instance index should be of the endpoint in each spline. So how to do that? We're just going to multiply this, the value from here, by the endpoint selection. Then we're going to change the start size to 0. Okay, then I'm going to connect this to an accumulate field node, and this is going to, and it's best to use integer, and connect it there. Then in the group index, I'm going to use an interpolate domain to say that these points should be of one single spline, and I'm going to connect in index. Okay, then connect the total into the instance index, and now it looks better, a bit better, I could say, although it looks as if it's one single point. Maybe I may sort of rotate this to something like this. Okay, they look as if they are in one single, from one single, they've only selected one of them out of all these 3. So let me see what's wrong. We have 5 points here, sample index, and let me check from here. We have 4 throughout, and the problem is there. I should go back to original if it is supposed to work well, and we should not reset the children for the lowercase. And now it's working correctly. This is actually what I was expecting, but the problem is this rotation that I did, I was just for viewing. We needed to sort of rotate in a way that a curve to mesh would keep its profile. So a curve to mesh refers to the tangent, the normals, and the radius of the spline when sort of giving its profiles, or giving the profile curve its position when it's converting it into a mesh. So we have to go back to this state before we first converted it into a mesh and sort of capture everything. So first thing is to capture a float attribute, and that float attribute is the radius of the spline, but this time sometimes it can be 0. So I want to connect in greater than 0 and a switch, and select true. So only when the radius here is 0, is greater than 0, then the value here can be accepted. If not, then it will be 1, like that. Next up, I'm going to capture the 2 vector values. So I'm just going to change it to vector. Then here I'm going to select the normal, and here I'm going to duplicate this and selecting the curve tangent. The curve tangent, as you can see. So I'm just going to connect the reroute. This is the one at the very bottom, reroute another one at the very top, and reroute, and Control Z that, reroute from here for the radius. Reroute somewhere there. So I just have to remember that this is for the tangent, this is for the normal, and the top one is for the radius. So I'm just going to grab this to somewhere there. Then this one here, which is the radius, I have to connect it to the scale. Okay, and everything is okay. The bottom one, which is the tangent, I'm going to use an align Euler to vector, and I'm going to select vector here, and this one I have to align the Z, okay, to the rotation, the first one, and it looks kind of accurate actually in this case. Then I'm going to duplicate this again, rotation to rotation, and this time I'm going to align the Y in this direction, which is the of the normal of the original spline, and we get simply something that looks like this. Then later we need to realize these instances. Then I'm going to re-sample this, and I'm going to connect in a geometry node input, and this one you don't have to do it by length. Like, don't do it by length because the result won't be good, it won't be accurate as what we are expecting it to be. So increase the resolution maybe to something like 30 to make it smoother, although this is not as smooth as would be expected, but yeah, that is enough for that part. So next thing is I'm going to shift Control D to select this part, and the other part that we have to change in this other set is this part in the instance index. Okay, so another thing that we have to do is duplicate this part. So select this, and this, and shift Control D to somewhere here. Take the total into the instance index, and this time we have to do for the start, and like this. Okay, so you can see that there is a change between these two. There is this one and there is this. Okay, I hope you can see that difference. So next up, I'm going to set the position. Okay, sort of smooth between these two shapes here, sort of smoothing. So that will be like the key of the lofting throughout this spline. So I'm going to connect in a sample index, then change it to vector, then here change it to position, and index, just connecting the index. And if I view this and just connect this vector value, this value here, into the position, we get the one that resembles like this one, which is perfect for what we are trying to do. So I'm just going to grab it to somewhere there, and next up I'm going to connect in the mix. This one set to A, and this B, I'm going to connect in the position. Then now if I connect the result into the position, this factor here gives sort of the smoothing between the two. Okay, that is what it gives. Okay, and yeah, everything is actually okay. So this factor here should be dependent for smoothing, such that it lofts, should be dependent on this, from this mesh here, should be dependent on the spline parameter factor from these curves that are coming from here. So let me just move this to somewhere up here, and maybe grab this somewhere there, and maybe capture that information, which is spline parameter factor. Connect this attribute factor into the factor like that. Now it has that sort of smoothing. Now what we have to do is sort of bridge from this to this, from one ring to another that we are seeing. And to do that is very simple. Okay, we're just going to first of all capture an attribute, and that attribute is going to be a vector, and that vector is going to be field.index value here and a position here. But in the index we're going to sort of add index plus the spline parameter length, I mean the spline length in the point count rather than the length itself. And that's all what we have to do. Next up, we're going to extrude these curves. So we have to first of all convert these curves into a mesh. Afterwards, we're extruding edges, not faces, and there is some restriction that we have to give, and don't worry, this is where we are approaching the end of the tutorial very soon. So I'm going to set the position of the very top, okay, based on this attribute that we captured here. And if you see now, and maybe I add in a merge by distance like that, you can see it sort of lofts here, okay, and at this very end here it sort of does its thing and comes to this very position here, which is something that is not good and something that we don't want to happen. And the simple reason is that this part here was once the end point of the original spline before this geometry node. So what we have to do, we don't have to extrude all edges, but we want to extrude all edges that didn't belong to the original endpoint, like the very endpoint. So what we have to do, we come back here again, grab this here, and we're going to capture an attribute, okay, and that attribute is a boolean, and this boolean is not, okay, boolean must not set to not, is not an endpoint which has the end size of 1, which has an end size of 1. So, and we connect this value here. If I just move all this way to somewhere, okay, somewhere, yeah, here, you can see things are corrected. And maybe you can set shade smooth, something like this, and you can see it's lofted, but we can see that the curves are too big. So simply what you have to do, you come back here, okay, and grab this somewhere there and just set curve radius, and we can now increase it to certain level. And the good part of this, it's very procedural, and we can change the normals by setting the curve tilt. So set curve tilt to add it there, and here I can connect in a multiply node. You can see it already started to change, and we can connect in again maybe a parameter, spline length parameter factor, like this, and you can see it sort of twists in this manner. Kind of looks good according to my eyes, actually. 0.1 maybe. It lofts and it twists at the same time. Kind of cool on my perspective. Okay, and that is lofting curves in geometry node, and I hope you enjoyed yourself listening to this tutorial, and it helped in it helps in making different meshes that looks beautiful with this method. And I hope you make cool stuff using lofting inside Blender. Thank you for watching, and I hope you subscribe if you like the content that I make, and see you next time in another tutorial. Thank you.